Hello everyone, I'm Xander with XPERIX and welcome to our podcast where I interview the hard workers of the engineering and design community. Today we have an incredible guest joining us today, a seasoned engineer who has not only made significant contributions to the field, but has also built a career that many aspire to. I'm excited to sit down and dive deep into his journey, explore the challenges he faced, and learn all about the groundbreaking work he's done throughout his career. From tackling complex engineering problems to pushing the limits of innovation, he has seen and done it all. So whether you're an aspiring engineer or just curious of what it's like to work in this field, you're in for a real treat today. So without further ado, hit that like button and smash that subscribe, and let's get right into it. So today I'm here with Simon, a engineer, and today we're going to get a little look at his life here. So can you please describe your education background and explain how it has prepared your career in engineering?
I did a traditional European apprenticeship, which is a 5-year academic and hands-on. So a company takes you on and they send you to college.
Interesting.
And then during the 5 years that you're there, you get the academic qualifications. The apprenticeship was in mechanical and production engineering. But when you're not at college, they own you. Oh. So all of the time that you're at the manufacturing headquarters or the engineering headquarters, you're learning all the different departments. So you go through everything from sales to working in the trenches on the machine floor to working in the drawing office, so that when you're finished, you know everything about the company. I think it's a lot better than just going straight to college than coming in kind of raw.
That's interesting. So I'm looking to go to Kettering, and that kind of has I'm probably a little bit different, but so I'm going to be going to like school for a little bit, and then I'd be going to work, and I go back and forth between. Is that kind of similar how it is?
I would say it's similar. It's not as hands-on. I know Kettering very well. In fact, the company I worked for until I retired, we had Kettering people in every spring, summer, fall, and generally they ended up being hired by the company because they were so good. Yeah. And because at the company I was working for, we would put them through all the departments. So you would put them in sales, you would put them in engineering, you would put them in design, and you would also send them to the plant to get hands-on experience. So I would say that is reasonably similar. Yeah.
Interesting. That's awesome. So what specific engineering disciplines are you most experienced in, and what projects have you worked on in those areas?
I've worked in the full vehicle over my career. The top 3 would be body in white, which is basically the entire structure of a vehicle. So it's all of the panels of the vehicle that come together to make the structure intact. So all of the doors, all of the Class A, which is the structure on the outside that's painted, and then everything that they have to put through a crash test. So that would be number 1. Number 2 would be what you call closure systems, which is the doors. The hood, the doors, the deck lid, all of that. And that's more of a mechanical systems thing.
For sure.
So it's all of the mechanical parts that actually make the doors open and close, all the windows go up and down, all of that kind of stuff. And then thirdly, when I started, I was in chassis, which is completely the opposite of all that. It's the steering, suspension, brakes, driveline, all of that stuff.
Interesting.
And as far as I probably spent most time in body in white, which is the body structure, and projects ranged from most of the North American automakers, Ford, GM, Chrysler, Nissan, Honda. We even had a couple of projects with the electric car companies, Fisker.
Really? So you were like everywhere, all over the cars and everything?
Yeah. Well, I worked for one of the biggest tier 1 companies, which was Magna. And they pretty much make everything on any vehicle except the glass and the wheels. So you had an opportunity. You were given, in fact, they stressed that they wanted you to work in each different department so that you could be all-encompassing whenever you got a project.
That's great. That's awesome. I hope Kettering's similar to that. So when you approach a problem, or how do you approach problem solving when you're faced with technical challenges in these projects?
Well, you have to face problems, because if you don't have any problems, you're not going forwards. Yeah. So there's always a problem. And I think the 4 things that you have to look at is, what is the problem? In other words, is it really a problem? Because there's a lot of times where the problem is not really as insurmountable as you think. Secondly, you need to put a plan of action in place. What is it that we need to do to make this problem go away? Thirdly, activate that plan, put it in place, make sure, follow it. And then the fourth one is when you get those results and you go back and look at the beginning, did we get where we wanted to go?
Interesting. Yeah, I mean, I'm guessing. I mean, I took an engineering class in high school, and like one of our main things was like learning how to overcome problems, because I've just heard and learned that there's like infinite problems in engineering when you're...
Engineering is a problem, waiting to be solved. That's it. Yeah, and it doesn't always require the most education, and by that I mean, you know, academic. It's amazing how many people in the field of engineering don't have the full academic background, but they are brilliant problem solvers because they can just look at the big picture,
for sure,
push everything out to the side and say, right, obviously you need your peers, you need peer reviews at any point during this so that you don't go off down a path that you shouldn't be going. But yeah.
Of course, yeah. Awesome. So can you discuss a time when you made a significant mistake in a project, and what have you learned from this experience?
Again, similar to the last one, if you don't make mistakes, you're not moving forward. So you make mistakes in every program. I mean, you have to. If you don't make a mistake, then you haven't probably got the best out of what you're doing. A significant one that comes to mind is when I was a resident engineer working at a Ford prototype development plant. I was a supplier to Ford. And I was the guy who every day when the parts came in to build the prototype vehicles, your parts had to be there. We had a big problem with shipping on time, and my problem became bigger when I realized that I wasn't actually giving all the information to the team, because if you're late, they all hate you. Because everybody else's parts are on time and they want to build the vehicle and they can't because your part's late.
Gotcha.
So I wasn't giving them full information about what the shipping was, how late it was going to be, where the parts were, and that made it worse. That was my mistake. When I became completely transparent, everybody suddenly wanted to help. It's amazing. It's one of those things that you learn. Instead of trying to hide something, you're honest, you're upfront and saying, it's not coming till Thursday. Then they can all make a plan and we move forward. So that was a big lesson learned.
Interesting. So were you like the leader of this project? Or?
Yeah, I was still working for Magna at the time, and I was the Magna, or a division of Magna. I was the Magna resident engineer at the plant. So whenever anything wrong with our parts, it was
on you. Interesting. Well, it must have been a lot of pressure.
It was. It was intense pressure. Yeah.
Wow. Well, I'm excited to go down this path. All right.
Finding your path is the most important one.
Yeah.
Yeah.
Definitely.
It's very easy to go down a path in the beginning of your career and then wish you hadn't. So it's whatever suddenly makes you excited is where you want to go.
Right. And that's why I'm going through mechanical, because it's so broad and so broad. There's so many different paths you can go down. You know, I started that, I was looking at biomedical actually for a little bit. I did this little camp at Michigan Tech.
Okay.
And we got to like look through all the different like research facilities and everything, and it would just blow my mind away, honestly. Like that's when I knew first, honestly, before biomedical engineering, I was looking at like just being like a doctor or like a PA or something. But when I saw that engineering stuff, I was like, yeah, this is me. You know?
Good. I'm glad that happened, because it's difficult. A lot of people these days, I know, struggle to find what their vocation is going to be. So I'm glad,
Yeah, that's great that I found that early, because ever since that happened, I was like locked in on engineering.
Excellent.
Like, this is definitely what I want to do.
Yeah.
What tools and software are you proficient in, and how have you utilized them in your past work?
My original career was straight out of college, and my apprenticeship was as a draftsman, so a designer. Okay. So the original tools I used were drafting tools, CGS, which was a General Motors original graphics system, and then CATIA. So I used those all the time when I was purely just a designer. When I went into design engineering, then there are the tools that you use for the program or the product that you're working on to keep within safety standards, corporate standards. For instance, there are tools that we use for GD&T, which is geometric dimensioning and tolerancing. There's design for manufacturing. There's design for process. There are tools, CAE, computer aided engineering, which is the analysis side of it. So all of those tools you have to use on a daily basis. And then there's the peer reviews, which is whenever you come to a point in your program management time, all of the other peers sit around and look at what you've got to say. And so those are tools that are available for everybody all the time.
Interesting. So I think I've heard like some of those, like CATIA. What was that one again?
CATIA is a CAD tool, computer-aided design.
So I've heard about that one.
It's the Dassault. There's 2 or 3 main ones. CATIA is owned by Dassault Systems, and then there's NX, which is owned by Unigraphics, which is Siemens today.
Yep, and that's what I'm learning right now.
Yeah.
Okay, so in your opinion, what are the most critical skills an engineer should possess to succeed in the industry?
A lot of the ones that I just mentioned, which are things you have to learn. There's the academic side of it, obviously. Those are skills that you need. But I think I said earlier, there is a big part of the industry that contains people that don't necessarily have those academic high level, but they're still great common sense engineers. Common sense is a skill that is so rare in society today, but in engineering it's absolutely required every day.
Interesting.
You can look at a mathematical solution for something, but if you have 2 or 3 people around that have got common sense, logic, look at things and see what it is, then that's such a great tool.
So would you describe your like your education background as like rigorous? Like, was that challenging getting through school?
Yeah.
Yeah?
Yeah.
Because I've heard like a lot about how catering is like extremely difficult, and
Yes.
like how people just like want to quit and fail. So like determination was definitely
Yes.
prominent.
Yeah. I don't know whether you know the history of Kettering, but it used to be called General Motors Institute.
Yeah, GMI.
Yeah, it was the GM. So it's deliberately hard because they want the best.
Yeah.
But I think it's like anything else in life, but particularly when things are hard, you need to work harder, because when you get your first project in engineering, it's going to be hard and you're going to come to a brick wall, and you'll see one day, I remember learning that.
Yeah.
And it'll all of a sudden become obvious.
Awesome. Yeah, I'm really excited to like put myself into that difficult situation. I like doing that and like making things hard for myself, you know.
Yeah.
I mean, that's how you do good. So how do you handle feedback and criticism regarding your work from your peers or supervisors?
Again, same kind of thing you've asked a couple of times. If you don't get that feedback and criticism, then you're not moving forwards. It's imperative. Of course, human nature is that you want to rebel against that and you want to push back, but you can't.
Yeah.
You need people around you to critique what you're doing.
Yeah.
And the really difficult side is to accept it. And again, this comes to the peer reviews. That's what happens in a peer review. You have your peers sitting around critiquing what you're doing, and you have to take what they say and move forward with it if it's positive. But you also have to stand up for yourself.
Yeah.
If you feel that you've done your due diligence and your design is correct, then you have to push back, because if you take another path that's been offered and it goes to a dead end, then you've just wasted time, resources, money, effort, everything. So taking criticism is good, but you have to also stand up for yourself.
So it's almost like you gotta try, you might fail, try, fail until you get it.
Yeah. If you go through a program and you don't have one failure and you get to the end, you haven't got the best product. You have to fail several times. It's expected.
Yeah. Design
Iteration is the most important thing. Most products will have hundreds of iterations before it gets released into production.
Wow. It's crazy. All right, well, what motivates you to work in engineering, and what are your long-term goals in this field?
What motivates me is what got me into this in the first place. When I was about 12 years old, I started taking engines apart, and I realized that this is what I wanted to do.
Of course.
So every day it motivates me to do that, and to make the best possible product for the best price, within budget, and to the engineering standards you've been given, is such a thrill.
Yeah.
It truly is.
Awesome. Yeah, that was like me. When I was little, I fell in love with Legos. I was literally obsessed with anything that was like intricate and you could make it into something amazing.
Yeah.
Oh my gosh, I loved it. I
What
love cars.
what was the second part of the question?
So what were your long-term career goals within this field?
Yeah. So my original goal when I got into the business was to work on a sports car platform program from beginning to end. Right from the very first design in the studio to when it's released to the public on set. That was the goal. I didn't quite complete that. I worked on some great programs, but not complete. I've worked on the full vehicle from beginning to end, just not on one project and not on the sports car program, but that's acceptable. I still feel very lucky. I'm towards the end of my career. My goal now is to take my Formula race car and turn it into a road car.
Oh, wow. So you own a Formula race car?
Yeah.
That's awesome. Is it like the real deal? Like
it's a Formula Ford. Yeah, you race it on the track. Yeah,
wow,
I've had it for 20 years.
That's awesome.
But I decided I was looking at buying a different vehicle. Like I don't know whether you know what a Lotus 7 is.
I do.
Okay. So I was looking at buying one of those or a modern day version of it, and then I thought, why don't I take what I've already got? I can race it on the track and I can turn it into a road car. So that I've also got, as Brian mentioned, 11 motorcycles which keep me busy.
So are they street bikes or are they dirt bikes?
Mix.
Mix?
Yeah.
So I've been a rider like my whole life. Like as soon as I was able to like ride, my dad got me a little 110, and you know, my cousins have a little place up north, and so we just like ride around in these little trails and stuff. It's awesome, dude. I love it so much.
Yeah, I have a complete mix of bikes. They're mainly old from 70s, 80s, 90s, but I am considering buying a new adventure bike this year because I want to go do some serious mileage.
Oh really?
Yeah.
So what's your favorite bike that you have?
It's impossible.
It's impossible. You don't
when I was younger, I always had a favorite bike. Now it's a bike for the task that you do.
That's very fair. You know, there's so many different types of bikes for different things.
Yeah.
But yeah, I think my favorite will always be like the trails. I love the trails. Like me and my friends, we would go in there. We'd spend like the whole day in the trails. We wouldn't eat a single thing. We'd just be out in the trails the whole day.
That is great.
Yeah, it's awesome. I love it. So how do you ensure that your designs comply with this industry standards and regulations? And I know you touched up on this a bit with the programs and stuff. Is there anything else that?
Well, you ensure it by several methods. Number one is the federal method, the Federal Motor Vehicle Safety Standards, FMVSS, which is what anybody who's working in the vehicle industry has to comply to. The corporation that's selling the car has to comply for crash tests and all of the other relevant, even lighting, vision. They all have standards.
Interesting.
But then a tier 1 supplier also has to meet that, because for Magna we would build complete vehicles.
Yeah.
So we actually have to pass those as well. So there's the federal level, and there's the corporate level, the company that you work for. Mm-hmm. They have their own. A lot of those are the things we mentioned earlier: the PFMEA, the DFMEA, the DFM, the GD&T, all of those tools that you're given, the CAE, that you're given those because they will tell you they will keep you within the specifications of what you're doing.
Gotcha.
And then of course there's the peer review, which you mentioned a couple of times, which keeps you straight and narrow, making sure you're on. There's system, subsystem, and component level technical specifications, which come generally from the OEMs. All of those are put in place to really keep you guarded against making those mistakes. Of course they happen, but if you have those, then you should be okay.
Interesting. So do you ever do you ever comply with the company's regulations, but then federally they're like, no, this isn't gonna work?
No, because the federal level is the most important.
Of course.
Yeah, it goes down from there.
Gotcha.
That's federal in this country. Of course, if you're selling the car in other countries, then you have to homologate that. There's a homologation standard, which means if you sell here in the US, it has this. In Japan, it has to have a different size number plate, different lights, different vision. Yeah. So every country is also different.
Interesting. So do they when they make cars in Japan, or let's say, and they ship them here, is it completely remanufactured? Or?
No, it'll just be the things that have to be different. Exhaust system, lighting, heating, mirrors, the number plate, the license plate is such an obvious one because every country has a different shape.
Yeah.
So that means that when you put it on the vehicle, for instance, if it's on the deck lid, in this country you'll see that the little flat space where the license plate goes is exactly the same shape.
Yeah.
In Japan it's like this long, so they'd have to make a new piece of sheet metal specifically for that area.
Interesting. So how would you consider your greatest, or what would you consider your greatest achievement, and in your career so far, and why?
There's more than one. It's been so varied. There was a program I worked on where we were collaborating with Daimler Chrysler. It's that long ago that Daimler actually owned Chrysler at the time. And we were building 3 sports cars on one platform.
Oh, interesting.
Dodge Viper, the Chrysler Firepower, and an AMG version because Daimler owned them. So we had responsibility for the complete underbody structure and all of the Class A sheet metal, which for me was a dream come true. It was fantastic. So I thoroughly enjoyed that. We worked right from the beginning in the studio with the clay models and the industrial designers. It was top echelon engineering.
Yeah, that's awesome.
Sorry,
I don't mean to cut you off. Was it the cars in general that you were just fascinated about and like what you were doing, or
the cars and the manufacturing?
Yeah,
it's always they'll spend more money on manufacturing on a sports car because they get more return.
Of course,
they're selling it for 100,000 and they can afford to do different manufacturing tactics on it. The body panels on this vehicle were not just stamped and pressed; they were what they call superformed, which they heat the aluminum and drape it. And it's actually the air that shapes it. It's very expensive, but you can get more dynamic changes in the surface.
Interesting.
So the car's one thing, but it's how you get there. It's great. The second thing was, I was lucky enough to be asked by Magna to set up a brand new engineering office for them in Mexico City. So I spent 3.5 years down there. And it was the complete thing, the infrastructure, logistics, employing the people, setting up the contacts with GM, Ford, Chrysler, Nissan, and all the rest of the people that were there. So that wasn't so much hard engineering, it was just a completely different thing, but it was, at the end of the day, it was probably the most satisfying, because when I left it, it was a running concern.
Interesting. So what company did you work for in Europe?
No, it was Mexico City.
Oh, it was Mexico City.
You mean before I came here?
Yeah.
I did my apprenticeship at a company called GKN. Which has a North American headquarters here in Auburn Hills. So they are suspension, brakes, driveline. So that's where I did my school and initial. Then I went to work for a company called Automotive Products, which is brakes again and transmissions. So that was all in the UK.
Interesting. So did that differ at all from how it is in US or?
Very similar.
That's what I thought.
Very similar.
Because you said they had like headquarters here, so.
Yeah, very similar. It's a lot bigger and a lot more. There's the UK car manufacturing concern was pretty much on its last legs when I left in the late 80s.
Gotcha.
GM, Ford, and Chrysler were world beaters, So you're coming to a place where they do it all, and they do it all better than everybody else. They've got more resources. I learned more in a very short period of time here than I had in the UK. So I think,
Well, that's awesome. Well, guys, thank you for watching. Make sure you like and subscribe, and have a great day.